Continuing on in section 3.6, a solution of a compound inequality involving OR is any number that makes either inequality true. To solve a compound inequality involving OR, we have to solve both the inequalities separately. Remember, ANDs we can keep as one inequality or write as one inequality, but ORs have always got to be kept separate. So here we're going to solve each individually. So to find our solutions here, we're going to solve for t. T's being added, so we get rid of it by subtraction. Whatever I do to one side, I do to both. Now t's being multiplied, so we get rid of it by division. And every time we multiply or divide with inequalities, we ask ourselves, do we keep or do we flip our inequality? And here, because I divided by a positive number, I keep that inequality. I'm going to do the same thing on my second inequality. I get rid of any addition or subtraction first. Then t's being multiplied, so I get rid of it by dividing. Anytime we multiply or divide, we ask ourselves, do we keep or do we flip? And here, since I divided by a positive or by a negative number, I go ahead and flip that inequality. So my solutions are t less than -3 or t greater than 1. So any number less than 3 or any number that's greater than 1. And keep in mind, with an OR, it only has to work for 1. Now to graph these, I'm going to plot my boundary points. At -3, I put a circle. I keep it open because it's not equal to, it's just less than. I want numbers that are less than -3, like -4. So I shade everything over here. And with ORs, since it only has to work for one inequality, I graph them just the way that they are, completely independent of each other. It doesn't matter what the other one does, because it only has to make one of our equations true, one of our inequalities true. 1 I keep open because it doesn't have an equal to, and I want my solutions to be greater than 1, numbers like 2. So I shade the side that has 2. And the gap in the middle shows that it's an OR. There won't always be a gap in the middle, but if there is a gap, it has to be an OR. Now, feel free to pause here and give this a try if you'd like. -2y plus 7 less than 1, or 4y plus 3 is less than or equal to -5. We're going to graph our solutions after we find them. To get y by itself, again, we solve each of these independently of the other. I subtract 7. Now my y is being multiplied, I get rid of it by dividing. Anytime we multiply or divide with an inequality, we have to ask ourselves, are we going to keep or are we going to flip? Here, because I divided by a negative, I flip. So I want numbers greater than 3. We have to have the word OR here. It tells us the relationship between our two inequalities. So simply having our two inequalities isn't enough. We have to say, what's the relationship between them? Does it have to be both? Can it only be one? What's the deal? So we have to have that word there. Now, to get rid of my 3, I subtract because it was being added. Being multiplied by 4, so I go ahead and divide. And I ask myself, since I divided, do I keep or do I flip? Here I divided by a positive 4, so I keep it and get any number greater than 3 or any number that's less than or equal to -2. Those are my solutions that we needed. Now we need to graph as well. I put both of my boundary points here. Keep in mind, negative numbers are on the left side of a number line relative to 0. Circle at both of my boundary numbers. 3, it's not equal to, so I keep it open, and we want numbers that are greater than 3, like 4. And at -2, it is equal to, so we fill in that circle. We want numbers that are less than -2, like -3, negative billions, and so on. And that is my graph. We can use an inequality such as x less than or equal to -3 to describe a portion of the number line called an interval. We can also use interval notation to describe an interval on the number line. So with interval notation, we use parentheses, brackets, and infinity Parentheses are used when it's less than or greater than, and endpoints are not included. So if we don't have the equals to, we're going to use parentheses. Brackets are used for if it's included, if the endpoints are included and we have the equal to. Here's how I remember that. A bracket is equals, just connected. So an equals, connected. So if it's equal to, we use a bracket. Or if it's a filled in circle, that tells us that it's equal to, and we use a bracket. These are open circles, and it's like half of a parenthesis. Or parenthesis is half of a circle, sorry. Infinity is used when the interval continues forever in a positive direction, and we represent that with our arrow on the positive side going to the right. So on a number line, if our arrow is shaded in, that means it's going to be positive infinity. And if our left arrow is shaded in, that means those numbers continue forever in the negative direction. That's going to give us negative infinity. So when the interval continues forever in a negative direction, we use negative infinity. Infinities always get parentheses with them because they are not exact values, they're more of an idea. It's not equal to infinity because infinity isn't a thing. We can always keep going by adding more numbers, but we use a parenthesis there because of that. Some examples here from page 203. We have x greater than or equal to 2 as an inequality. They graphed it here. To go from interval notation to inequality notation, the easiest way to do that until we get a lot more comfortable with these guys is by graphing. So I would graph your inequality or your interval notation and then switch to the other form. So here, for interval notation, we start from the left and we go until we see part of our solution set. The very first thing I see from the left is this 2. So I write down the 2. It's a filled in circle, which means it's got to be the bracket. The shading on my number line, okay, that's my comma, and then I have an arrow shaded in. Since it's in the positive direction, that's infinity, and again, infinity always gets the parenthesis. Second one, x less than 2, well, starting from the left, the first thing I see is this arrow. Remember, arrows are infinity, and since it's on the negative side, it's negative infinity. Infinities always get parentheses. Then I see shading on my number line. We represent that with the comma, everything in between. The last part of my solution is at 2. So I put the 2 down, and since it's an open circle, it also gets a parentheses. So it matches here. Here, going from the left, the first thing I see is 1. So I write down a 1, it's an open circle, it gets a parentheses. There's shading on my number line. That's my comma. Last thing I see moving from left to right, and we go left to right because that's how we read sentences, math, graphs, anything like that. I put the 5 down. Because it's a filled in circle, I put a bracket. It means it's equal to. Remember, equals. Here, first thing I see is this left arrow, negative infinity. I see shading on my number line, and an open circle at negative 3. Open circle means parenthesis, infinity means parenthesis. This gap in the middle shows me that it's an or, so I can put or here. Because I have 2 separate inequalities graphed on the same number line, it has to be an or. Then I see a 4 with a closed circle, which means it's equal to, so I use a bracket. Shading on my number line, comma, and this arrow is shaded in, so positive infinity, and again, infinities always get parentheses. So they have the interval notation there. We could also go from interval notation to a graph to inequality. Either way there, we can go forward or backwards. Here we're going to start an interval notation, graph it, and then write it as an inequality. So my graph, the first thing I see from the left is going to be a negative 4, so I put a negative 4 on my graph. I put a circle there. Because it's a bracket, it means that's equal to. My comma means I'm going to shade along my number line until I get to 6. I'm going to put a circle at 6. That circle is going to stay open because of my parenthesis there. So my graph looks just like that. Now to put this as an inequality, keep in mind that my x is my shading in between. That's my variable. That's all of my answers. And right now that's between -4 and 6. So between -4 and 6, it's equal to -4 and it's not at 6. So -4 less than or equal to x less than 6, or x is between -4 and 6. For part B here, first thing we're going to do is graph it. So at -1, I have a point. I want it to be equal to, so I fill that in, and I want numbers that are less than, like -2. Then I have a point at 2. Since it's not equal to, I leave that open, and we want our numbers to be greater than 2, like 3. And everything off over here. The gap in the middle only happens for ORs, so we're good. Now, how do we write it in interval notation? Starting from the left, just like how we read a sentence, like here we start with what and move right, same idea with a graph. The first thing we see is this arrow. And since it's on the left side, that's going to be negative infinity. And infinities always get parentheses. We see shading on our number line. That's our comma, everything in the middle. And then it stops at -1. And since that's filled in, that's going to be a bracket. Gap in the middle is my OR. Then I have another point at 2. Since that's an open point, it gets a parentheses. Shading on my number line, comma. The last thing I'm going to see here is that arrow. Since it's in the positive direction, it's positive infinity, and infinities always get parentheses. So here is interval notation. Here's my graph. Here's inequality notation. Now, feel free to pause here and give this a try. We want to know what is the graph of -2, 7, and then how do we write it as an inequality here? So -2 is the first thing on the left, so it's going to be the first thing I write down. 7 is the last thing on the right, so it's going to be the last thing I write down. And then numbers on each side. And 0. I put circles at those boundary points. It's the start of my graph on the left, the end of my graph on the right. At -2, I have a parenthesis, so I keep that open. I have a comma in between the -2 and the 7, so that's going to be my shading on my number line. And at 7, I have a bracket, and that tells me that it's equal to, so I fill that in. Here's my graph. Now, to write this as an inequality, keep in mind that our shading in the middle, okay, that shows us where our solutions are, our x, our variable. And that's in between -2 and 7. So to show in between, we do less thans. -2 is less than 0, for example, and 0, for example, is less than 7. So they both have to be less than symbols. At 7, since we also filled it in, it gets an equal to. So here is my inequality. Okay, here we're going to graph y greater than 7. I'm going to keep it open, and I want numbers greater than 7, like 8. So my graph looks like this. In interval notation, we look, moving from the left, the first thing I see is, a circle at 7. So I write down 7, that's my first thing on the left. Since it's an open circle, it gets a parenthesis. I see shading on my number line. That shows me that in between the two things, my comma, I have my solutions. And the very last part of my solution is my arrow, which means infinity. And infinities always get parentheses. Keep in mind we go from left to right. So here is interval notation. Here's my graph. And there's my inequality. Quick recap here. The solutions of a compound inequality are either the overlap or combination of the solution sets of distinct inequalities. The graph of a compound inequality with the word "and" contains the overlap of the graphs of the two inequalities. Has to work for both. Whereas the graph of a compound inequality with the word "or" contains each graph of the two inequalities because it only has to work in one. It can be in the first one or in the second one. And that's all I have for section 3.6.